Now we're going to learn to draw Lewis structures from molecular compounds. As I showed you in the previous examples, if you draw the elements in the compound and then ensure that each one will share its electrons to make sure that everyone has 8, then your structure will be complete. This is a method to use, and sometimes it works when you have trickier compounds if you want a method. But the other method I showed you works just as well for the most part. So, step 1 says arrange the symbols of the elements in the compound so that the element with the largest bonding capacity is in the center, surrounded by the elements with smaller bonding capacities. So, if I was in this case of methanol, I'm going to put carbon in the center with a bonding capacity of 4. Oxygen has a bonding capacity of 2. I'm going to put it to the right of it. And then so each hydrogen has a bonding capacity of 1. Then I will count all the valence electrons for all atoms in the molecule. And this total will represent the total number of electrons that can be used in the Lewis structure. So carbon has 4 electrons. Oxygen has 6 electrons. And there are 2 hydrogen atoms, so we have 2 electrons, and that is a total of 12 electrons. The next step says to place 2 electrons or a single covalent bond between the central atom and each of the surrounding atoms. So carbon is the central, so we'll place 2 electrons between that and oxygen, and then 2 electrons between that and hydrogen, and then the next hydrogen. So then it says place lone pairs of electrons around each of the surrounding atoms except hydrogen to satisfy the octet rule for each surrounding atom. So for carbon, there are no more lone pairs of electrons. So we still have our 2 electrons here. Oxygen has 2, it needs 6 more to have a full octet. Hydrogen does not need any, because it only needs 2. Okay. Step 5 then says determine how many electrons are still available to use by subtracting the number of electrons you have used so far from the total number of valence electrons. So, how many electrons have we used? 2, 4, 6, 8, 10, 12. So there's no more left, right? So none are remaining. We used 12 electrons. We used 12 electrons. So then it says place the remaining electrons on the central atom to complete the octet rule for the central atom. So let's do that, because if we look back to this one here, carbon only has 2, 4, 6. It needs 8. So we must place 2 more between the carbon and oxygen. That's the only place we could to make this happen. But if we do that, that means we're taking 2 from oxygen and putting them into, into the bond right here. So that's what we've done to get our 2 electrons between carbon and oxygen, so that carbon will have a complete octet. Okay? All right, step 7, and I didn't show you that, so there it is. That's what we did. We took the 2 electrons from around oxygen, put them into the bond, so that oxygen now has 2, 4, 6, 8, carbon has 2, 4, 6, 8, and each hydrogen has 2, which is what it wants. Okay? Step 7 says, if the central atom does not have a full octet, move lone pairs from this out. Well, we did that. Okay, we move lone pairs from the surrounding atoms into a bonding position between the central atom and the surrounding atoms. This will introduce double or triple bonds between the surrounding atoms and the central atom. We did that already. So again, that would be this. This is why this method sometimes seems a bit redundant, especially when you have a simpler molecule. And we don't do really hard ones overall. So most of the time you should be able to use Make sure everything has 8, use this bonding capacity and move the electrons until you get a full octet. Then it says, replace the shared pairs of electrons with dashes to represent the covalent bonds. Use double or triple dashes for double or triple bonds. So we only have one double bond. And step 9 says, choose the most symmetrical arrangement of atoms around the central atom. Arrange their surrounding atoms equally spaced around the central atom. Essentially, we've kind of done that. I mean, if you think around, you know, in the bond, you have a circle which is 365 degrees. So if you really wanted to make it super equal, you'd probably do it a little bit more like that. Right, this is 365 degrees. So spread your bonds around equally. And there you go. There you have it. That is a method for doing Lewis structures of compounds, molecular compounds.